Welcome to Health and Veritas. I'm Harlan Krumholtz.
And I'm Howie Foreman. We're physicians and professors at Yale University. We're trying to get closer to the truth about health and healthcare. Our guest today is Dr. Stephen Waxman. But first, we're always checking in on current or hot topics in health and healthcare. So where do you start, Harlan?
Yeah, Howie, today I thought I'd talk a little bit about this Humana investor meeting that just took place. You know, these big companies have these investor meetings where they pull together all the information. Of course, it's from their perspective and they're, trying to put their best foot forward. But there were some interesting things about it. And a major thing about it was how much money they have lost because of the lack of bonus payments from the federal government related to the way that they are performing on the quality measures. And big company focusing on that. So let me talk a little bit about that. By the way, Humana is basically a Medicare Advantage company today. It started off by, as you know, as a hospital company, and then it evolved to an insurance company. And now it's really focused so intently on Medicare Advantage. So at their investor day this year, they laid out a strategy to stabilize and grow earnings by 2028. But the near-term story is one about damage control. And our group at Yale, we spent a lot of time talking about quality metrics and how you can bring greater accountability to healthcare. Well, in Medicare Advantage, there's a very important rating system that rates the plans by stars. And this is important because it's tied to reimbursement. It's tied to bonus payments. And in 2024, 94% of Humana's Medicare Advantage members were in 4-star or higher plans. And in 2025, just 25%. So that meant that the majority of their plans won't receive the quality bonus payments. And that actually had a very big effect on their revenue for the next 2 years. And what was interesting was this wasn't due to a catastrophic decline in quality, as much as it was to a complex set of technical and executional issues related to the stars themselves. So the stars underwent a little bit of a change. They created a tougher grading curve, sort of more aggressive statistical methods, including ones that kind of cut out outlier performance and sort of made it so that it was, they thought more stable. They also, key star measures like medication adherence, hemoglobin A1C control, annual wellness visits had been reweighted, and their thresholds had been tightened so that now small misses in what the targets were having bigger consequences. And then Humana themselves said they had some gaps in execution. And maybe a few large contracts were having a disproportionate effect because when those fell below the 4 stars, that meant a large number of their customers were no longer in the 4-star area. I just thought it was interesting because, these companies are investing so much in hitting these marks. They have financial consequences. And when the sort of cheese moves, they go after it. And so it just doubles down on the importance of this as not just PR or hearing about it as someone picking a plan, but that the plans are paying a lot of attention to them. But it's going to be really important that these measures are valid and that they're helping to point them in directions that are going to have really good effects on the people that they're covering.
I think it's fascinating to hear from you because you've been involved in the technical development of measures about the Humana situation, because the Humana situation really is about an insurance company that owns the CenterWell practices and other primary care practices, trying to figure out how they can deliver good care and make money at the same time. And understanding the STARS system is central to that. So thank you.
All right, let's get to our interview with Steve Waxman.
Dr. Stephen Waxman is the Bridget Flaherty Professor of Neurology, Neuroscience, and Pharmacology at Yale University. He served as Chairman of Neurology at Yale from 1986 until 2009 and is the founder and current director of Yale's Neuroscience and Regeneration Research Center. Dr. Waxman has also served as the director of the West Haven VA Center for Restoration of Function After Nervous System Injury since 1999. Dr. Waxman's research has made pivotal contributions in identifying the role of ion channels in human pain and leading to the development of the first non-addictive pain medication. His recent work focuses on pinpointing, quote, pain resilience genes and restoring function after nervous system injury. He received his bachelor's degree from Harvard and his PhD and MD degrees from Albert Einstein College of Medicine. He completed training as a postdoctoral fellow at MIT, as a resident at Boston City Hospital, and as a clinical fellow at Harvard. And prior to coming to Yale in 1986, he held faculty positions at Harvard, MIT, and Stanford. So Harlan and I got incredibly excited when Harlan talked about the sort of culmination of your research in this new drug that was being approved by the FDA to treat pain with a non-opioid substance. And this is sort of a holy grail. I mean, we have witnessed untold numbers of deaths and other harms from opioids. We have a lot of side effects from opioids, so many problems with pain. When I mentioned to my father about who was going to be the guest this week and told him what your work was, he just paused and said, I don't think there's anything more important than that right now. And he genuinely means it. It is just, an incredible journey that you've been on. And I just wondered if you could start off by telling us, people think about these discoveries as happening in a 1 year or 3 year time frame. How did we get to where we are, and how important is this moment in time for pain research?
To me, one of the exciting things about this particular discovery is that it really represents and reflects the arc of science, which, as you said, doesn't necessarily have one pinpoint eureka moment. There are many. And in this case, the arc of discovery begins in 1945, right after World War II, when two scientists in Cambridge, England, Alan Hodgkin and Andrew Huxley, were studying nerve fibers, axons, in the squid. And those axons are particularly large. They're called giant axons. And so in 1949, studying these axons for the first time, they were able to record electrical activity, and they were able to predict the presence of molecular batteries that enable nerve cells to signal sodium channels. They did this work in 1949. They published it in 1952, and they got the Nobel Prize in 1963. The arc then moves to Yale 25 years later, at the turn of the century, when we picked up the baton and began studying the role of these channels specifically in pain. 1997, then another set of studies in 2001, and we did a bunch of studies, and it eventuates in the development of a new class, an entirely new class of medicines that target a sodium channel that's in and only in peripheral sodium channels that are not present in the brain. So it's really, I think, a very nice demonstration of how science moves clinically. It's not a perfect drug, but we've demonstrated now that we have proof of principle that by targeting these peripheral sodium channels, you can reduce pain in humans with no addictive potential. So that's the story.
Steve, in various places we hear about like these families, even in literature, in fiction, sometimes people are writing about families that either don't feel pain or they do feel pain. And actually, there's a real world story that you were able to leverage that helped unlock some of the secrets for your lab. I wonder if you could tell us a little bit about that. The man on fire syndrome.
Sure. As we've moved the science ahead, we've done it in several ways. One is sort of ground up, beginning with the involved molecules. So we know that sodium channels act as molecular batteries. We know that there are now several types of them. And the holy grail had been, might there be a type of sodium channel that's present only in peripheral nerves, not in the brain? We found that. And then the question was, is it important functionally?
Let me just ask you one thing for clarity for people listening. What do you mean by the batteries of the nerve cell? Like when you say the sodium channel is the battery, can you just explain for folks who aren't, familiar
Sure,
with this, what you
that's a
mean?
great question. So, our nervous system, in every one of us, our brain and spinal cord, consist of 100 billion nerve cells. Within our bodies, the nervous system is the world's most complex computer. 100 billion nerve cells. They talk to each other, they communicate with each other by producing nerve impulses. Each of these impulses is a thousandth of a second long and a tenth of a volt, tiny, but they're electrical impulses, and they are produced by molecules called sodium channels. When Hodgkin and Huxley did their work, they predicted the presence of sodium channels, but it was almost as if it was a singular entity, one type of sodium channel. And it wasn't until the late 1980s that, as the molecular revolution rolled in, it became clear that there was not just one type of sodium channel. There were NaV 1.1, 1.2, 1.3, and then a bell went off. Hey, might there be a type of sodium channel present in and only in pain signaling neurons? It turns out there are three: NaV 1.7, 1.8, 1.9. My lab at Yale is pretty much the international hub for studying those sodium channels. So one way of doing it is looking at pain signaling nerve cells, putting the channels in and out, which we can do using molecular methods, and asking what does each of these channels do to facilitate pain signaling. And that's work that we've been doing for very, very many years. But another way is
Let me
to
ask you just one quick thing on this, just to explain. So, do you mean, for example, you can take a mouse and knock out one of these receptors and see then what happens? Is that how you do it?
We can. So we can knock out one of the channels, but we also can take a channel and put it back in. And we can do substitutions of that sort. We can put in a channel that we've altered. And right now we have a technique called dynamic clamp. This is a really exciting technique. So right now we're taking rat pain signaling neurons. We have them in a dish under exquisite control. We're controlling everything. And we want to study the effect of the sodium channel NaV 1.8. It's the target of the new class of non addictive pain medications. How much do you have to remove? How many of those channels do you need to block? What we do is in these cells, they're rat pain signaling neurons, is we humanize them. We use very powerful electronic technology to remove the currents from another channel that's making them active, and we put in the current from a gain of function, what we call an overactive channel that's causing a very severe pain syndrome, the man on fire syndrome. So we put that current in, and now under control, we have, under exquisitely controlled circumstances, we have a pain signaling neuron. It should be silent, but because it contains this pain signaling channel, it's going crazy. That's what causes patients to feel immense pain. And now we can ask, using this electronic circuitry, what happens if we remove 10%, 20%, 30% of the NaV 1.8 channels? It's as if from New Haven we're eavesdropping on a string quartet in Cleveland. We can isolate every one of the instruments, and we're at the point where we can tell what happens when a mouse crawls across the room. So it's very, very rewarding technology, but it's letting us dissect channel by channel what's happening. So that's one set of things we're doing at the mechanistic level. But you asked about the genetics and the families. Another way of studying molecules, including sodium channels, is to look for families that have mutations of these channels. We began in 2002 looking for families with inherited neuropathic pain.
Can you just say for a moment what neuropathic pain is? Because some people might not be clear
Sure.
about that.
Neuropathic pain is pain due to disease or dysfunction of the nervous system. And so the most common causes of neuropathic pain are diabetic neuropathy, or the neuropathy associated with chemotherapy, post shingles neuropathy. And in each of those cases, peripheral pain signaling neurons that should be silent are going like a machine gun. They're firing on their own when they shouldn't, and that is sending a pain signal to the spinal cord and then to the brain. So that's neuropathic pain. Now, the two of you are internists. You know that neuropathic pain is very common. We see it all the time in our clinics, but we essentially never see families with inherited neuropathic pain. So why invest a lot of effort surveilling the entire North Hemisphere to see if there are families? And an analogy is the development of the statins. And again, you know that story very well. The development of the statins depended in large part on discovery and then study of incredibly rare families, with everybody getting heart disease at an early age. Once those rare families were found and their genes were sequenced, that pointed the way to the lipid pathways. So we have been doing the same thing for pain. We have families with overactive sodium channels, gain of function of sodium channels, and they have severe, excruciating pain. And there are families with loss of function of these channels. They don't make the channels, and those families have a striking picture of total insensitivity to pain. Painless fractures, painless burns, painless childbirth, painless tooth extraction. So both sides of the coin, that's called genetic validation. That's been one way of going at these channels. The second is, as I said, this mechanistic dissection, channel by channel. What does each channel do to the behavior of, pain signaling nerve cells?
There are an awful lot of people that would sort of retire when they step down from being a chair, as you were. And you were not just a chair for a few years, you were a chair for many years. You built an important department in the medical school. You've, if anything, your research has taken off during this time. And right now, again, at a time that many people would be enjoying their grandchildren, and I'm sure you do, uh, people pause and do other things. You are probably more active now than you've ever been in so many different ways, and you're going to receive a highly coveted award, the Sharpie Schaefer Prize for Pain Research, coming up next year, and I believe it's from the UK Physiologic Society, or the Physiologic Society, I think, of the UK. Can you just speak to how you're able to, number one, maintain the energy that you have and to be as active as you are, and what motivates you moving forward?
Yeah. Well, number one, I really have learned how important colleagues are. My research team is second to none. I'm at a university which has been so incredibly supportive. The environment is second to none. I have a spouse who is the booster rocket. I couldn't do what I do without Merle.
And a
So
great
all
friend.
those things are key, and I guess I've always been curious. I've always loved science. I was chair of neurology at Yale for 24 years. That's probably 14 years longer than any sane person would do it. But for me, stepping aside from the chairmanship was an opportunity to continue the privilege, and it is a privilege of doing this kind of work. You mentioned grandchildren. We do spend a lot of time with them. They're each special in a special way, and we treasure that. And you mentioned the Sharpie Schaefer Prize. That's a prize, the prize given by the British Physiological Society for translational physiology, physiology that makes a societal difference. They give it, it's a triennial prize. They give it for the most important discovery every 3 years, and it's gone to a couple of Nobel Prize winners. When you mentioned family, it also reminded me that in 2009, I heard that I had been nominated for the annual prize of the Physiological Society. That prize had gone to Hodgkin. He got the Nobel Prize. It went to Huxley. He got the Nobel Prize. It went to Eccles. He got the Nobel Prize. So that prize had gone to all my heroes, and now I was nominated. You can imagine I really wanted that prize. And so that was I think 2009. I heard I'd been nominated. Then I heard, Steve, you're on the short list. Somebody called and said, Steve, you're going to get it. And then I did not get it. I didn't get the prize. I didn't look back. I just didn't look back. A year later, I did get the prize, 2010. So now I had the prize, and I looked back. Who aced me out a year previously? Who aced me out? And it turns out that I was aced out by a man named Robert Edwards, Sir Robert Edwards. He got the prize for developing IVF.
Oh, wow.
Well, he gave me and Merle two beautiful grandkids. They are more important to us than anything. Think of the gift he gave to the world. And so that taught me that prizes are great, but there are even more important things than prizes.
That's a great story.
So in my family, they sometimes make fun of me because they say they think I have a low pain tolerance. I think they say that in jest, but now can I tell them that just might be genetic because my little sodium channels activate blah, 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 a little bit more than theirs. So it's not just a matter of my will that I give in to pain, but it's maybe that actually I'm getting more signals than they are. Do you think that's possible?
It is possible. Um, Look, pain is a very complex phenomenon, and it really illustrates the challenge of gene versus environment. And undoubtedly, environment plays a role. That's why we send Marines to Camp Lejeune to toughen up. But our nervous system also, our genes tune the level of pain that we feel. And we actually have begun looking at genes that confer pain resilience. We have these families with the man on fire syndrome. So each of these families
And
carry
just to
all,
and just say for a moment what the man on fire syndrome is, just to be really clear about it.
we, for years, wanted to find families with inherited neuropathic pain. We found them. The medical name is inherited erythromelalgia. The more common name and a very evocative one is the man on fire syndrome. These people feel searing, scalding, burning pain in response to mild warmth. Putting on shoes, wearing a sweater, going outside when it's 72 degrees, and they feel pain that they describe as feeling as if hot lava had been poured into their bodies. They will. The pain is so severe that opiate abuse is common. Some of these patients will ask for limbs to be amputated, and it doesn't help. And we're very invested in trying to find medicines that will help them. But all of these patients carry gain of function mutations of the NaV1.7 sodium channel in peripheral nerves, mutations that make that sodium channel too active, overactive, and that's what drives the inappropriate firing of their pain signaling nerve cells. Now, you mentioned inter-individual differences. In these families, everybody who has the mutation feels severe pain, usually. We have maybe 20, 25 families in our data bank. Two of these families have one outlier, and that outlier carries the pain causing mutation, but has very little pain, and we've wanted to know why. Is it that that person went to camp and toughened up when they were a teenager? Or is it in their genes? And so, what we do is we study those families in great detail. We follow them for 13 weeks, everybody who get a pain profile in them. Then we study in each person in that family, we study all 23,000 genes. And we're able to take from each of them cells, make stem cells, and differentiate them into pain signaling neurons. And what we found is that in the pain resilient people, there's a mutation in another channel called a potassium channel, a KV channel that acts as a brake. It slows down the firing of pain signaling neurons. So that is a pain resilience gene. There undoubtedly are others. There will be a number of them. But having that in hand, we now are working with a biotech company that has a drug that targets that gene and activates that channel. And so we're taking a sort of multiple approach on goals.
Can I ask you, this is an unusual question. You're welcome to say you don't want to answer it even, but very often in academic medicine, we put people or promote people into chair positions based on their accomplishments, very often on their scholarly accomplishments. In your case, where you are such an innovator and a thinker and a scholar, and where I could see how much contributions you're making during these recent decades, and I'm sure you were making them during the chairmanship as well, is it a good idea for us to be taking these amazing researchers and, quote, rewarding them with chairmanships or chairwomanships, when in fact it's taking them away from what they do best? I just wonder if you have any advice to our listeners, many of whom may contemplate this at some point.
That's an important question. I spend a lot of time with younger people sharing my views, and the fact is that while I was chair, my productivity was high, but I did not have time to enjoy the
Mm,
science, and more important, I didn't have that those free moments when you sit down with a trainee and you say, just let's get a cup of coffee and talk. And so there's no question that there was a trade-off when I was chair. Would I do it again? I think so, but I might organize my weeks differently. But I do have a story. It's about a colleague uh, whose age matched to me. And so when I finished my residency, I was an MD, PhD, assistant professor at Harvard and MIT, and this colleague was at another major institution, also an MD, PhD. And we used to talk on the phone, and I'd tell him what I was doing, and he'd tell me what he was doing. And he would say to me, remember, we're new assistant professors. We're 32 years old. He would say to me, Steve, what are you doing to prepare to become chairman? And I'd say, but Bob, I'm just setting up my lab. What are you doing to become chairman? And he reeled off, I'm on this committee and that working group. And so I said, Bob, why do you want to become chairman? And he said to me without a hint of humor, because that's how you become dean. Well, he went on to become provost at a major university and then president of another university. And fast forward to a few years ago, I would speak to him on the phone and I would say, Bob, it's amazing. I admire you so much. You can erect 10-story research buildings. And he would say, Steve, you're doing real research at the bench. And I tell the story to my trainees because they have a choice. They don't have to say yes. The good trainees are going to have lots of opportunities, and I had the opportunity to be considered for major deanships. I decided I didn't want to do that, and I think that every one of our trainees needs to titrate these things. But the important thing is to know is that they have options. They do not have to say yes.
Well, we're at the end, Steve, but I just want to ask you one thing because we're in a moment with NIH and talking about budget cuts and all these kind of things. You're talking about these marvelous discoveries. How important was the NIH support to you?
NIH support was absolutely incalculable. Period. The dollars were beyond necessary. They were ultra necessary, and beyond that, the support, the sort of psychological support, knowing they cared, with NIH administrators calling up to say how you doing, urging young people on, was an added booster. So I can't even put numbers on it. That's how
I mean,
important.
just to make the point clear, though, the work that you've done for the most part is not commercializable until the very, very end when you're actually developing a product. You can't get to this point where you have a product without doing this all public interest work that basically is not patentable, but very much inherently critical.
Howie, that's absolutely true, and I'll leapfrog you because a lot of what's going on in my lab is driven by curiosity.
Right,
What happens if we alter this molecule or
right.
that molecule? We don't quite know where it's going, and that's how science advances.
That's right. That's great. Well, thank you so much for joining us and for just doing what you do. Because quite frankly, again, you could have paused your career years ago and done other things, but you've done this, which is to the public benefit. So thank you.
What a joy to have you on. Regards from us to Merle, and very best as your work continues to flourish. We continue to look for great things from your lab and from your work.
Thanks, Howie and Harlan.
So, Howie, that was a great interview with Steve Waxman. What's on your mind this week?
Yeah, so I mean, there's been a few pieces of news that have come out in the last 2 weeks, roughly, related to Medicare that I thought were really useful to just highlight for our listeners. And if you recall, back in early April, so not that long ago, I talked about the conflicting data out of the Congressional Budget Office suggesting that the Medicare program might be more financially solvent than it had been noted to be previously. And I pointed out that mostly the final word on this matter would be left to the Medicare trustees. And their report, which finally came out last week, not surprising in a new administration for it to be a bit delayed, that report came out this week. And rather than showing what the CBO said, which is that Medicare was doing much better, it actually showed that it's doing worse. It's now expected to be technically insolvent in 2033, which is 3 years earlier than the prior report predicted, and 19 years earlier than the CBO report predicted. Now, first, this only applies to the hospital insurance part of Medicare. That's called Part A. But the new report really is concerning. It showed surprisingly higher spending on healthcare this past year for Medicare beneficiaries, and also included numerous points of concern going forward, mostly related to the unsustainable nature of a lot of current policy. We've touched on this in the past as well. All told, there are good reasons to believe that the federal Medicare program, what we think of as Part A, the hospital program, is headed for disaster, perhaps even made worse by recent policy changes regarding Medicare Advantage, because in early April, the new administration announced increased payments for Medicare Advantage. This would not have been captured in this new analysis, so we've already got more problems going ahead. As a greater majority of Medicare beneficiaries move on to Medicare Advantage plans, the cost of these plans is also becoming a more acute, a greater attention for us. And this was also addressed in another report from the Medicare Payment Advisory Commission, what we call MedPAC, in their mid-June report. We've talked about this before. Every March and June, MedPAC issues a report. Stat News summarized the entire chapter, the part of the report that's important to me at least, with one title, which is Medicare Advantage's supplemental benefits will cost taxpayers $86 billion this year with little transparency. Couldn't have summarized it better than that. It's been 22 years since the passage of the Medicare Modernization Act and the introduction of Medicare Advantage that followed, and there are many good things to say about the program and its intent, but it is still astonishing to me that we don't have a simple answer to some basic questions. Is the program more or less costly than fee-for-service Medicare? Is it better or worse quality? And is it more or less expensive to the beneficiary? And the last story I want to tie together to get to the absurdity of this issue is a company called Semler Scientific and their product QuantaFlo. This technology was marketed as an easy way to screen for peripheral arterial vascular disease, a very common problem in a large number of our beneficiaries. Used properly, one could imagine that this technology would allow us to identify patients at risk earlier, treat them, and preserve function. It's not a bad idea. It sounds really good. But it turns out that what was the technology mostly used for? It was mostly used to risk adjust, which is another way of saying increase payments for Medicare Advantage payments, and particularly by, you guessed it, United Health Group. So there was no indication that this resulted in any better care for patients or prevented or treated disease. The entire business model for this company seemed to rely on risk adjusting patients to receive higher payments. As if that story is not crazy enough, now that the company has been stymied in this strategy because Medicare changed their rules and United Health Group drew the scrutiny of the Department of Justice, the company has now pivoted to a new strategy. They are plowing all their money into Bitcoin. At some point, we're going to look back on this period in history and laugh, I think, or maybe we'll just cry. Nonetheless, it reminds us that the Medicare Advantage program has been gameable and seems likely to remain gameable with unclear benefits, except to shareholders or other providers, perhaps. Bottom line, as Congress moves on from whatever becomes of this big, beautiful bill that we've talked about and its enormous impacts on Medicaid, we will once again be left to address fundamental issues about Medicare sustainability and how to support this critical program that provides health and healthcare and financial protection for our elderly, disabled individuals, those with end-stage renal failure, and patients with amyotrophic lateral sclerosis or ALS.
That's a great segment, Howie. The two quick things I'll say. One is I keep hearing about how it's going to run out of money, and then it sounds like yada, 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 because I don't know, I'm really curious whether the sky will fall at one point. But, I think for those of us who aren't on the inside, we're just wondering, does that really mean anything? And will Congress actually do anything about it, or how's it going to go?
Congress did two things over the last 2 decades that made a big difference, 3 decades now. The Balanced Budget Act in 1997 added decades to the program, and then Obamacare, primarily through taxes, but also through reduced Medicare Advantage payments, was able to extend the life expectancy of the trust fund. Short of something meaningful like that, we will hit a wall. Now, I agree with you. The point is to raise alarms now and get people to act on it before you get to the absolute crisis moment. The closest we've ever come, I think, is 4 years right now, with 2033 being the number, we're 8 years out. So we're not at quite a crisis, but we have a lot of work that we have to do and come to grips with the trade-offs that have to be made with providing this enormous trillion-dollar program.
Yeah, those still sounded like Band-Aids. I mean, they gave you extra decades, but they didn't really create a large-scale, long-term sustainable program that could stand on its own.
That's right.
And the last thing I'll tell you is totally agree with you about gameable. I've got this great idea to solve the gameability problem on a future episode. I'm glad to share it with you. But actually, I have
love
an
that.
idea about
That'll
this.
be a lot of fun.
Yeah, I have an idea about how to fix that. You've been listening to Health and Veritas with Harlan Krumholtz and Howie Foreman.
So how did we do? To give us your feedback or to keep the conversation going, email us at health.veritas@yale.edu or follow us on LinkedIn, Threads, or Twitter, or Blue Sky.
Yeah, we really appreciate your feedback. Rank us on the platforms, send us notes. We always enjoy hearing from you.
And if you have questions about the MBA for Executives program at the Yale School of Management, reach out via email for more information or check out our website at som.yale.edu/EMBA.
The Health and Veritas podcast is fortunate to be sponsored by the Yale School of Management and the Yale School of Public Health. And we are doubly fortunate to have two of the superstar undergraduates that we have, Gloria Beck and Tobias Liu, to have a marvelous producer, Miranda Schaefer, and for me to have the very best partner in the world, Howie Foreman.
I agree, right back at you, and I appreciate all of them that really do make a huge difference.
Yeah, talk to you soon, Howie.
Thanks a lot, Harlan. Talk to you soon.